Here is the second video to the exam review. We left off with number 11, or number 10, so here's number 11. So they want us to write the expression in exponential form. Remember, we can write the exponent as a fraction, like a over b. B would be the index, and then a would be, or whatever it is we're raising to the power of a. I'll show you what I mean. If it's the fifth root of 3n raised to the eighth, the index is in the denominator, and we can write it like this. If we're trying to go in the other direction, given the rational exponent, and we're trying to write it in the radical form, this tells me it's the cube root and then squared. 7b. Now, I like to write it like this. It's the cube root and then square afterwards, kind of like how they have in this example. You wouldn't be wrong if you wrote 7b raised to the third, raised to the second in the cube root. I think it's easier, especially if we have to work with any numbers, to take the radical and then raise it to a different power than it is to like square it and then take the cube root. All right, so when multiplying the radicals, they need to have the same index. So like 2 square root 6 times square root 5 is 2 square root 30. And then 2 square root 6 times square root 6 is square root 36, or 2 times 6, 12. So 2 square root 30 plus 12. If you can simplify, like if this was the square root of 32 instead of 30, I could write this like the square root of 16 times the square root of 2, and then write it like 4 square root 2 you should. But 30 doesn't have any perfect squares where I could simplify it. This is what my final answer would look like. Remember that I is equal to the square root of -1, and I squared is equal to -1. This would be -5 times 7. -5 times -i. 5i times 7. And 5i times -i. So -35 plus 5i plus 35i. And if this is I times I, it's -i. So it's -5i squared, or plus 5. -30 plus 40i. When we're adding or subtracting the complex numbers, we're going to, like if it's a plus bi plus c plus di, it's a plus c. And some books might write this like a or b plus d, and then factor out the I, but I'll show you what I mean with that. First thing I want to do if I'm subtracting is change the sign to make this -4 plus 6i. We're going to add the opposite. -4 minus 5 is going to be -9. 6i plus 3i is 9i. For number 16, it's not going to tell you that you need to, it's not going to tell you that you need to multiply by the conjugate, but here the conjugate would be, we're going to multiply the numerator and the denominator by -3 minus 2 square root 3. So in the numerator, this looks like -12. Oh, sorry, not -4. Minus 8 square root 3. In the denominator, this is going to be -3 times -3 is 9. Negative 3 times the negative 2 square root 3 is plus 6 square root 3 minus 6 square root 3 and then minus 4 square root 9. So these are going to eliminate. I've got 9 minus 8, or sorry, not 8. 4 times 3, so minus 12. So we got negative 12 over negative 3. We're taking away 8 square root 3. If we wanted to factor out the 3, it's not going to work with the 8. You could, if you wanted to, write this as negative 12 over negative 3 plus 8 over 3, or square root 3. So you get 4 plus 8 over 3 square root 3. Sometimes you'll see this, especially for complex numbers, that they'll simplify what could be one of the, real parts of the complex parts, but I would be fine with this answer. The other thing you might want to do is factor out the negative and just make it 12 plus 8 square root 3 over 3. All right, in number 17, I can add up my radicals if they're like radicals. So negative 2 square root of 9 times the square root of 3 minus 3 square root 3 plus 2. This is going to be the square root of 9 times the square root of 6. This becomes negative 2 times 3 square root 3 minus 3 square root 3 plus 2 times 3 square root 6, or negative 6 square root 3 minus 3 square root 3 plus 6 square root 6. So these two are like radicals, so I can rewrite this like negative 9 square root 3 plus 6 square root 6 for my final answer. Similar thing here, negative 2 square root 3. I can't simplify that. 24 is going to look like 2 square root 4 times the square root of 6 minus 2 square root 9 times the square root of 6. So negative 2 square root 3 plus 4 square root 6 minus 6 square root 6 to get negative 2 square root 3 minus 2 square root 6. So for number 19, if I'm trying to complete the square, the first thing I need to do is isolate the variables. I don't want to have this 46 on this side. I just want n squared minus 14n on one side of the equation. So to isolate, I'm going to subtract 46 on both sides. So n squared minus 14n is equal to negative 48. We're going to take the coefficient in front of the n, or like the linear term here. Negative 14 divided by 2 is negative 7, and negative 7 squared is 49. So I'm adding 49. I get n squared minus 14n plus 49 equals 1. The whole point was to turn this into a trinomial, like a quadratic, that I can write as a square. Now whatever you took for this number divided by 2, it's going to be n minus 7 here equals 1. I'm going to take the square root on both sides of the equation. I'm left with n minus 7 equals plus or minus 1. If I add 7 on both sides, n equals 7 plus or minus 1. N equals 6 and n equals 8. One thing we didn't mention, Tom, but I'm going to bring up at the review, is that the quadratic formula works, quadratic formula works when it's ax squared plus bx plus c equals 0. So I need to subtract 75. So it's opposite b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Or we get negative 10 plus or minus the square root of 100. This is going to end up being plus, and 4 times 75, 2 times 75 is going to be 150, times another 2 is 300, over 2, negative 10 plus or minus the square root of 400, over 2, the square root of 400 is 20, divide 10 and 20 divided by 2 is negative 5 plus or minus 10. So you get x equals negative 5 plus 10, and x equals negative 5 minus 10. X equals 5. Or x equals negative 15. All right, and then the last 3 I have on this page, or on this document, are going to be finding the discriminant. I'm going to save this for the next video. I'm also going to add about 3 more questions to this, and we should have all of the setup for, well, I guess tonight, Saturday. But email me if you have any questions. There'll be one more video, and good luck.